Has anyone not heard of Bitcoin? I do just want to, because it's okay if it's new to you, and if people are watching at home, do they need to know what Bitcoin is to understand any of this? Because it's possible people are watching and they don't know what Bitcoin is.
Absolutely. So for those who don't know, Bitcoin is a new digital currency.
Cool.
Right. And it's not backed by any government. And it's just kind of like people are calling it the currency of the internet, and it's all digital. Like it doesn't exist in the physical world at all. Right, and it's been getting a lot of news coverage. Sometimes it's actually pretty bad.
Why is it bad?
Because like imagine like the early days of the internet, like the early 90s, and the first community that got attracted to the internet were like people who were trying to do like some shady things or some illegal things online. Bitcoin kind of like went through the same phase where initially, you know, a lot of the usage might not have been completely legal.
People were buying drugs.
Yeah, people were buying drugs, and like that, and that's also a very like clickbait story.
Yeah.
So it gets a lot of coverage, but like Bitcoin has been around for 7 years now. And
I didn't know that.
There has been a lot of like investments. More professional firms have stepped in. There are a lot of like very interesting use cases which are coming up, and this technology is growing. So imagine like if early 2010 was like 1992 for the internet. So we have grown over the last like 4 or 5 years, but we are still like pre-Netscape era. There's no like browser for this technology where you can like just go and use it. But let's come back to this question of like why would you have a new currency? Like what's wrong with the world right now? Like everyone is, you know, we have cash, we have bank accounts, we have credit cards, the world seems to work just fine. For that, I will like ask everyone to kind of like take, kind of like go to a higher level and try to imagine that maybe we are just used to the world being the way it is, and try to envision that, hey, things could actually be better, right? So the first thing is that currencies, so fiat is a currency that is like, you know, think of it as like a more traditional government-backed currency. They're actually not very stable. We don't feel that in the US, right? But if you look at the rest of the world, like, so I was born and raised in Pakistan, and people would not keep their savings in the local currency. They would actually either buy gold, or they would actually buy the British pound.
Because it's more stable.
Because it's more stable, right? So they don't want to just like have their savings in the local currency and then after 4 years see that it actually went down in value. So this is a chart of the Chinese currency versus the dollar. And there was a massive hit in around August of 2015 that not a lot of people actually noticed that this happened. But a lot more people noticed when Brexit happened. Right, and the British pound took like a massive, I think this was between 25 to 30% hit in value, because imagine that these currencies are tied to whatever the government is doing, right? And if your government is not very stable, like you live in, I don't know, somewhere in Africa, Argentina has had massive problems. So these currencies are actually not stable because they're tied to a particular government, right? So if we can design a currency that doesn't have that constraint, that'll be pretty cool. The next thing is that our currencies, to operate them, you depend on a lot of infrastructure. Like think of the banking infrastructure, right? But the banking infrastructure is not like the internet. It's not open. You can't just like innovate on top of it. It's actually closed source. Only banks can access it. And what ends up happening is that you get charged all these fees. Like why does it charge $40 to send a wire? It makes no sense. Right? Banks are able to extract that money because they have a monopoly. Right? If all of the banks are charging at least $40, that's the price you pay for sending a digital wire from one place to another. Right? And then there's all sorts of overhead. They're slow. They can like introduce new fees and you can't really do anything about it because they control the infrastructure. It's closed source.
So you're saying like one of the problems with the fact that money is tied to countries is, and physical banks, is that because they have this monopoly, they can charge us whatever, and we don't have control of the money. They have control
so
of
it's
the money.
like different levels of control, right? Like the governments have control in a different way, and then these institutions, banks, which are like really private sector, but because there are so few of them, and they kind of the infrastructure is closed source. A good analogy is like the way I think about it is if you go back to the 90s again, it's kind of like the Linux versus Windows.
Oh yeah.
Because Windows was you had to pay a license. It was closed source. People can't just edit it, make any changes. And then Linux came along, and again, initially it was clunky, and only like these nerdy developers were working with it. But if you look at the market for data centers or servers, Linux is by far the winner. Right, it's the more stable operating system. Now it is. It's completely taken over.
But it was really radical to think that this free open source.
Unthinkable that this free open source thing that any developer can basically hack on would actually take over the product from the biggest company out there, Microsoft.
Awesome.
Right, but it happened because open sourcing things actually enables innovation. So the point here really is that right now, the rate of innovation in this industry is actually being slowed down because of closed source infrastructure that banks are sitting on. Right.
That's awesome.
And another interesting thing is the current payment methods are not very friendly towards your privacy. Like everyone has seen these online forms where you have to enter your credit card information, your name, where do you live, before you can actually make a payment. And there is no equivalent of cash online that I can just like give you like a $5 bill and without any information on like here's my number and here's my street address, and we can actually do something about this as well. So I think to summarize, basically our system right now is not very simple, and users don't have a lot of control. By that what I mean is that you can't really put a lot of cash under your bed. I mean, people do. They go and like some people go and buy gold or like fill up their mattresses, right? Because they don't trust the banks. Like, but that's not the norm, right? And because it's like physically hard to manage all of your cash, right? And then you have to put it in banks, but now you're really dependent on the services that the bank is providing. And it's not just the banks, it's also the payment processor. So if you look at PayPal, if you're a merchant and you use PayPal for accepting payments and PayPal shuts down your account, suddenly your business is in trouble, right? And it happens to a lot of people, especially outside of the US, where PayPal would suddenly just shut down your account and you're like, okay, what do I do now? My website is going down. I can't accept payments anymore, right? So, and the other layer of dependence is like eventually you're tied to countries and governments. And if, let's say, I was born and raised in Pakistan, if something bad is happening in the country or the government is not very stable and the value of my currency is going down, like I'm losing money and it's not my fault, right? Because the government is like, did something wrong, it's not stable anymore. But so at a high level, we are dependent on all these large companies and governments, and maybe there's a better way, right? Like maybe we can actually design a global system for digital payments where we are not dependent on any of these parties. And that's where Bitcoin comes in.
Awesome.
What we'll do now is we will actually try to design a new currency, see how that works, and if we can make it work, right? So remember the main requirement that we cannot be dependent on any single party or like big organizations in the middle, right? So let's say we start off, this is a professor, Brian Kernighan at Princeton, and we, let's say, have a piece of paper. It's very simple. It could be a piece of paper on this table over here. And we start off by saying that Muneeb has 10 coins and Brian Kernighan has 10 coins, right? Both of us are in the room. Like we could do this exercise like right here as well. And Paul Krugman, who's actually is funny, he's also a professor at Princeton, but he's a big critic of Bitcoin. Like he's like, sure, I want to join this thought experiment as well. Like, what are you guys up to? And he joins in, and we say, you have 0 coins. I want to get him started. I basically send him 2 coins, and the transaction is unconfirmed, right? So imagine like it's literally a piece of paper, and then we say the transaction is confirmed, and we update the balance. right? So my balance goes down, his balance goes up. And because everyone is sitting in the same room, we have the same view of reality, there are no conflicts, right? But as soon as someone outside of that physical space, let's say Bill Clinton from Seattle, wants to be part of this system.
Bill Gates?
Yeah, Bill Gates. Yeah. Yeah, I think I've been watching a lot of like Donald Trump.
Yeah, you're in it.
Exactly.
Okay.
So, and now someone wants to send money to Bill Gates. How do we reconcile what is real now? Because like his view in Seattle could be different. Like his piece of paper is a different piece of paper from our piece of paper.
So you're saying like if we're all in the same room and like somebody gives you money, it's like we all saw it.
Yes.
So we can confirm that happens.
Exactly.
But if we ask somebody like Bill Gates who wasn't here, he has no idea.
And now imagine doing that at a global scale, right? Where the way that people are interacting with this system is through their computers, right? And I'm saying I sent Chris $10, and everyone else on the internet is like, did you, or did you not, right? How do we know? Like the entire banking industry kind of like exists there because Bank of America can step in and say, yes, he did send Chris $10.
Got it.
And then that's how things work. So what we are going to do is, I think we're going to like switch over to the board and like try to actually see how we can design this. All right. So let's say these are your laptops, right? And you guys, the lecture is over, you guys went back home, right? So everyone's sitting at home, right? And we are doing the same experiment again, where we are saying, this is Muneeb. This is Chris. And I'm saying that I'm sending $10 to Chris, right? And this is the entire network. Like no one else matters. Like only, like this is our world right now, right? And let's say Lee says, yes, looks fine. This transaction happened, right? Over here, there are two nodes left, and for some reason they disagree. They're like, no, Muneeb didn't send the money, right? Now, how do we reconcile what actually happened? Right? And one obvious way people would be like, well, maybe the majority should win, right? Like there were 3 votes here and 2 people here. We can say, well, 3 people are saying that this happened. Maybe that should win. This guy, let's say it's Mr. Evil.
Mr. Evil?
He's like, wait a minute. I have 2 other laptops just lying in my drawer. I can just bring them up online, and now I actually have more votes. Right? It's the same person, but he's just like plugging in more laptops into the system and saying like, listen to me, this transaction did not happen. Right? And this is where our scheme starts to like break down, that anyone can just go and try to overtake the network. So how would you ever design a system without this like massive, let's say Bank of America, or like you can insert any other bank here, and we can go to this bank for conflict resolution, that hey, did this happen or not, right? So this is precisely the problem that Bitcoin solves. And what they do here with Bitcoin is, like, we know that we have to go to some party or need to have some mechanism to resolve conflicts. What Bitcoin says is, we will design a way where society can collaborate with each other and come up with a way of resolving conflicts without putting any single party in charge. Right? So it kind of like replaces this like big brother in the middle by saying everyone gets to be a part of the network and no single party can actually take it over. Right? So now I'm going to get into how that works. So Now, imagine something like a video game, right? And time moves forward. Like imagine you're inside a video game and time is moving forward, and this is like time 1, time 2, time 3.
It's like seconds or minutes.
It could be seconds, minutes. It could be any fraction of time,
Okay,
right?
okay.
Time is just moving forward, and any changes that happen in that world can only happen in basically steps in time. Right? Like I was standing here, I'm making a move, I'm moving. Now in the next T2, I'm actually standing here, right? So you can imagine transactions in a similar way, that in this time slot, the $10 were in my hand. In the next slot, I gave it over to Chris, right? So like the same principle applies. Now with Bitcoin, everyone who is part of the network imagine that they are kind of like processing the video game, right? Like every node that is part of the network, they're kind of like processing this environment where time is moving forward. And let's say there's a conflict. Let's say around, this is the part of the network that says that T4 is this. And then there are a bunch of nodes, for whatever reason, who say, no, T4 is actually this. And so now there's a fork, right? Like some part of the network is saying Muneeb transferred $10 to Chris. Another part of the network is saying, no, he didn't. So now like there's a fork in reality. And like we are trying to figure out which version of reality are we actually going to say that, hey, this one is true.
It's like the same thing. It's like, did Muneeb get $10 or didn't he?
Yes.
And there's like a disagreement.
There is
you're
a
like,
disagreement.
which one do we choose?
Right. And the way Bitcoin solves this problem is to be part of the network. All of these nodes are constantly solving these puzzles. They're like computational puzzles, and they get new puzzles at every time instance. Everyone's solving them, right? And whoever gets the solution gets to basically write the new block of time. Right?
Whoa. Whoa.
Yeah. So this is Bitcoin's way of solving that problem I talked about, where someone just went and plugged in more laptops to the network, because now it's not about how many people are on the network, but how many computers are on the network, and how many computers do you own. So I might own like 3 of these, and someone else might own like 2 of these, or someone might own 100, but everything translates into how much computing power do you have on the network, right? And then everyone gets like this puzzle that you're solving, and then whoever comes up with a solution says this happened. So now there's a conflict, and this part of the conflict, they keep moving forward, right? Because things are happening in the world all the time. There are other transactions that are happening. So they kind of like continue with their version of reality, while other people can like disagree and try to continue in a different version of reality. What happens is, if the majority of the computers are on one version, that version basically progresses faster or has like more computing power behind it. So this one like dies off because people have incentive to jump over to the version that is actually longer or has more computing power.
Cool. Do you think we could open up for a few questions?
Yeah,
just
sure,
to
absolutely.
check in and see, because I feel like
So this part, by the way, was the most complicated part of like how Bitcoin works.
What would cause the discrepancy? Like, why would one computer think a transaction happened and another would not?
So there could be multiple reasons. Some of the reasons, the nodes might be trying to be malicious, right? Like I want, let's say it's censorship. Let's say that some companies or some governments did not want something to happen, so they're saying this didn't happen, right? And
or you're trying to steal money, hack money,
someone
like
is trying
any
to
of
steal
that,
money,
right?
someone is trying to block something from happening, or it could be they didn't have malicious intent, but there was a network partitions and they just didn't see the data, right? And they're not trying to be malicious. They actually believe this is the version of the reality. Like imagine in our example earlier where Bill Gates was sitting in Seattle. Let's say for some reason he didn't hear about a transaction. So he actually believes that, hey, this is the version of reality, but he's just out of sync.
I think and this might be a little high level, but if you are a coder and you use GitHub, a good analogy, like if you use GitHub, sometimes two developers are working on a project and one person can make a change and the other can make a change at the same time. And then there's a conflict and it's like, well, which one are we going to keep kind of? And then you kind of have to resolve that.
Even the same thing happens with Google Docs.
Google Docs.
Shared docs, right? Like, let's imagine that there was a version of file that you were working on.
I got it, yeah.
And then I edited it, but Chris also did it.
Like
and
at the same time.
Like we need to merge this back in, right? But imagine that there's a conflict resolution mechanism where I can say, hey, Chris, I'm going to take your changes. I'm going to put them here. Are you fine with it? He goes like, yeah, sure. Let's just go with this version. Or we'll discard a version. So what's happening is you're discarding a version and saying, no, this is the view of the world.
Yeah.
Because that's the majority view, right? But the way that they decide on what's the majority is the complicated part, right? Because the majority is decided in a way that no single party can just like take over and suddenly become the majority. Like I can't just go and buy like 100 computers and come back in and suddenly like, hey, I'm going to take over Bitcoin. You can do it, but you'll have to spend at this point like maybe $200-300 million and then manufacture these chips. And like basically it's extremely hard to do even for a state level actor. Like even if you're a government, you'll have to spend a lot of resources and money and actual hardware before you can attack the network. And then still people would notice.
And is it clear, Chris, that like this used to be, or because currently is monitored by banks? Like if there's a conflict resolution, you're like, well, you go and see your bank statement, and it's like that's the answer, right? And so the change, or in this new currency that is being developed, this is all public. So does that mean that it's a lot more likely to be maliciously, or does that mean more mistakes are more likely because it's public or open source? Or
I think it's basically it's more auditable because the information is public, right? And I think there's a difference between privacy and the system being more public and open. Like nobody really knows who you are because you are represented as this random string of numbers. That's your address. Right, and it's not your bank account address because you can change it very frequently. It doesn't really matter. So nobody really knows who you are when you make transactions, but the history of transactions is public. So anyone can go back and audit them all the way to the beginning of time. Whoa. And the beginning of time is when Bitcoin started, right? So in a way, so this fascinates me because Bitcoin is not just the currency that the internet never had, it is also the sense of time that computers and the internet never had. Like they don't have a sense of like how time moves forward and how you can roll back time and go back to an earlier state.
Whoa.
So that's
cool.
Yeah. Cool. Other questions?
So can somebody hack it and steal money from others? Or?
Yeah, absolutely. So that's a I'm saying absolutely. That's a great question.
We're going to show you how.
Yeah. So what happens here is actually I'm kind of like thinking maybe I should run through the slides a little bit and then
come back to this.
Come back here because there is some information there.
Because it's a lot to like digest.
Yeah.
This is complicated.
So the first thing is like this is not science fiction, right? Like when you introduce someone to this concept and they go like, yeah, sounds like some weird theory, may or may not work. And then when you tell them that, hey, this is not science fiction, this is Bitcoin, right? So it started in 2009, like January of 2009 was what they call a Genesis block, like the first, the T like call it 0 or
the
something.
First transaction, is that right?
Transactions are in blocks.
I got it. Okay.
Right?
Got it.
So like this is not even on the chart.
Okay.
I discovered it here. 2013. I was supposed to like finish my PhD. I was working on a different thesis. I just kind of like, me and my co-founder Ryan Che, we just went all in. Like, this technology is like, it's a rabbit hole, right? Like, you can just like keep discovering new things, and you can
I
just
heard a rumor that you may have put all your life savings in Bitcoin.
Yes, but
Is this true?
But
Okay.
to be fair, I was just a poor grad student, and it wasn't a lot of savings, but I did convert all of them into Bitcoin. And Lena, she
Your
was
wife,
like,
yeah.
she was like, you're crazy. Like, but the good thing is, like, she did not
She did not put her money
into Bitcoin. So yeah, I was taking the risk, and you can imagine I was very happy here when this went from, I think when I got in, it was less than $200. I was like in the late 100 range,
Okay.
and then it went up to $1,200. Right, so I was feeling very smart at that point, like when it was here, and then there was a crash, and then another crash, and it was stable. But what's interesting is, all of this has happened before. Like, this could be a zoom in, like this could be a zoom into this.
It does look similar to
Right?
that. Yeah.
Like, it's like just, it's the technology. Like, think of it this way, that when email was starting, people didn't have email addresses, right? And then you would bring someone on board by making them create an account and sending them an email, right? But now there is actual money involved with the adoption of this technology, as more and more people are like joining in, and the total number of Bitcoins are actually fixed. So it works like gold in that way. Like, the price the only way forward is the price to go up, because the number of Bitcoins is fixed. Anyway, so like, it's been around. We have actually been developing a lot of technology on top of it. I'll talk a little bit about it later. This is interesting. So if you go back, the first question that people were asking is, okay, it's a digital currency, but will anyone ever accept it? Like, can you actually buy things with it, right? And interestingly, the first known transaction for anyone actually accepting Bitcoin for an actual good or product was a pizza in 2010. Right, so this guy sent 25,000 Bitcoins for a pizza that the other guy was saying the pizza is worth about $25.
That's an expensive pizza.
It's an expensive pizza.
This is a pretty good pizza.
And if he didn't buy that pizza and still had 25,000 Bitcoins, that'll be worth around $1.5 million today.
Whoa.
So that's was
an
a
expensive pizza.
Extremely expensive pizza.
Was that you?
No, it
Yeah.
wasn't. This happened in 2010. I got in 2013.
Oh,
Like 3 years
was
before.
that you?
Yeah, I would be a sad man sitting somewhere in a corner. And if you look at the Bitcoin industry now, around 1.1 billion US dollars has been invested just by venture capitalists, like VC firms, like people who put money behind Facebook, Amazon, Google. They're all getting into this space. And these are like some of the big companies. We actually share investors with these guys, like companies that raise like north of $100 million, right? And to build like wallets for Bitcoin, to build like merchant services, to build like, they're a very interesting company, 21. They are building like Bitcoin computers that just come with this mining chip, so that whenever you're kind of like just minting money through your computer, and it has like built-in Bitcoin support, so you can just like make payments at any point, and so on. If you actually wanted to, so now this brings me to like, okay, how is the currency actually created? Like, who creates it? If there's no government, how do you actually distribute the currency to begin with, right? And Bitcoin solved this problem in a very interesting way, that they tied the release of the currency with the same thing, like this thing. So at every block, new currency is being released.
So as you go through time,
So at every step of time, like, imagine someone is like throwing new money into the system.
where does it go?
So it goes to so now, remember when I said that all these people are solving puzzles, right? So imagine like it's us, and we designed this system that is going to give the person who solves the puzzle a reward. The reward is actually new Bitcoins that are getting introduced. introduced into this system, right? So all of us are like solving a puzzle. Who else says, hey, I solved it, right? And I get Bitcoins. So this is how new currency gets introduced into the system. And as this, initially it was just people with their laptops. And then people started getting more sophisticated. They started like building like what they were calling them mining rigs in their basements. Like they would make a lot of noise but they were actually literally minting money.
So mining is like using a computer
to make money.
Or to solve puzzles?
To solve puzzles.
Okay.
To make money.
So you solve puzzles, you make money.
Yes.
Okay.
And then this happened, right? That this is a mining rig.
Whoa.
So imagine someone's basement where they're actually like going around trying to do you have friends who are like big video game players and they have like these really sophisticated computers and they would make sure which video card they're using and how much RAM they have? Like take that and multiply that by 100x. These guys would go and optimize like their machine so that their machine is actually more powerful on the network so that they can get more money, right? And then professionals stepped in and they started manufacturing what are called ASICs. They're specialized hardware designed to do only one thing, Bitcoin mining.
Whoa.
Right. So so imagine a computer that cannot run any other calculation. The only calculation it can run is Bitcoin mining, and it's optimized for that. So they reduce the price of that computer, but it's really, really fast on like basically solving the puzzles.
Wow.
And so those ASICs jumped in, and now actually it's not profitable for people like us to connect your computer and actually make money.
That's awesome.
Yeah, so this is something what I kind of described, that there are 21 million Bitcoins in total. Around 75% have been released already.
Of all the Bitcoins that
All
are
the Bitcoin
ever
possible.
going to be released.
Going to be released.
Who decides that?
This is when, so imagine it was 50 Bitcoins per block. Like when that guy bought a pizza for like 25,000
right.
Bitcoins.
Yeah.
Like he was probably mining for a while and collecting like 50 Bitcoins per block and then decided to spend them. And then it dropped in November of 2012 to half. So it's like, imagine the protocol is reducing the rate at which money is being released into the system because they thought that people will realize how valuable Bitcoin is over time. So initially there's more supply, but less demand. And now the demand is going up and the supply is kind of like going down. And it's very interesting. So Bitcoin actually halved again last month, and now Bitcoin was like big enough that there were actually like Bitcoin parties all over the world, like Tokyo, San Francisco. People were like, for some reason this was like a big event where now suddenly it went from $25 per block to 12.5 Bitcoins per block, right? So this is going to go down to zero in the next, I don't know, like 70 years or something like that.
Is it because of inflation is what you're saying?
It
Because
is.
there's so many of them.
So imagine, so governments do this, right? Like governments would figure out what's the inflation rate for the currency. So this is inflation built in at the beginning. Everyone knows the rate, right? And then it's going to stop at some point. So we actually don't know what will happen, but it's actually, the point is actually pretty far away in some sense. But if it keeps reducing in half, like you can imagine it'll go down to 6, then 3, then 1.5. So actually that time is not that far away. So we might hit like less than 1 Bitcoin per block in I'm assuming decades, a couple of decades. So then it will be very interesting to see, do people still connect their computers to the network? Because that's not the only form of payments. So we have been looking at this as a currency, and blockchain is like this thing, right, that just keeps growing. And that's the kind of like, think of this as like a journal or a data structure. In computer science, like, there are different types of data structure. It's a new type of data structure or technology. And interestingly, it's a file. So you might have heard the term blockchain, and people have like some sort of vague idea about what it is. if you want to look at a blockchain, it's literally a file. You can download it, right? Like it has a file with like different like subfiles in it. And this file only grows, like imagine like it can only grow in one direction. You can never erase data from it. You can only add more data to it, right? So in that way, it's like a journal. As you fill some pages, you can fill more pages. You can attach like another like extra pages and keep filling them, but you can never erase data. That's what a blockchain is. And anyone who wants to participate in this network has like a full copy of it. Like in terms of like if you want to be a miner or if you want to connect to the node, like normal users don't need to have a copy. They can just sign transactions and send it out. I'll explain how that works in a bit. So this is the example of like, a bunch of people, they want to be on the Bitcoin network. So it's a network in the sense that everyone can talk to pretty much everyone else. And I talked about leader election a little bit, where one node solves the puzzle and gets to write the new block, right?
That's a little complicated. What?
So so the problem over here is, so here's the problem we're trying to solve. It is a network of computers, and we have this blockchain, and a new block is coming in that is going to give this person 50
like new
Bitcoins.
Bitcoins is like
Right.
what we're talking about. Okay,
Yes.
okay.
So who gets it? Everyone will try to get it, right? It's real money. Like they can just actually convert it to dollars like straight away. And so they are all trying to solve a puzzle, and whoever solves the puzzle, maybe turned out to be this person, gets to write the new block and get the Bitcoins. Right. So this is a way to have like this system in place where no single party is in control, because there's no guarantee that this person will get to write the next block as well. Because when the next block is coming, you go back to solving the puzzles, right? And it's very random. Yeah.
Why are they together then?
In the sense that why are they collaborating?
Yeah.
So they're all not really collaborating with each other. They're all playing the game. They're on the network.
Okay.
All of them are saying, I want to play, right?
So they're like competing.
They're kind of like competing.
Yeah.
Yeah.
Okay.
And so now, like, I'm going to switch gears. This was more about like how the protocol works internally. But for most users, they don't need to know all of this, right? Like, they're like, hey, I just want to use this thing. How do I use it? And how does that work for me? How is it more secure? Like, how is it more private? So now we're going to like go a little bit into that, and then also explain like how, as a user, you would interact at a slightly more technical level as well. So what happens is that there's this concept of a private key and a public key, right? The private key is your secret. Think of this as you're literally your key to your house or something, right? Like, you're not supposed to give it to someone else. You're not supposed to share it with anyone else. And the public key is kind of like, think of that as like a pair, that the public key can be derived from the private key, and that information you can share with anyone, right? So, but because no one knows the private key other than you, no one else can prove the ownership of the public key, right? Let's do it again.
Yeah, try it again.
Okay. So imagine two large numbers, right? They don't mean anything. They're like gibberish. Actually, I can show you. This is what a private key looks like.
That's like your bank account number. Like you get one of these.
You can't derive it.
Okay.
That comes later. But imagine like gibberish, right? Like just very, like, imagine an extremely strong password where you just like start typing like crazy and you come up with something like this, right?
Okay.
That people would not be able to reproduce it. Like, there's like very low probability. This secret, extremely long, very secure password can be converted into a public key that is okay for you to share that public key, right? So imagine that it's like the private key kind of like owns the public key, but the public key is shareable. You can tell people that, yeah.
So is what we're trying to solve or talk about is like how you can keep security, but
Yes.
also have all your transactions public.
Yes, it's basically like imagine if the analogy is the Facebook username and password.
Oh, okay,
The
yeah.
public key is the username. You can tell people your username or Twitter handle, right? The public key is kind of like your Twitter handle, but the private key is your password that you're supposed to keep secret. Otherwise, someone will steal your Twitter name because they will just be able to log in,
Got it.
right?
Makes sense.
So that's what private and public keys are. And whenever you think of private keys, just imagine like you typing on a keyboard like crazy and coming up with this number. Actually, even that would not be that random. There are mathematical properties behind how random this number is. That to generate it, you would need more energy than is present in the universe.
What?
Like so that goes back to your security question. So if you actually don't share your private key ever with anyone, like no one can just randomly hack you.
So it's very secure.
Like from a theoretical perspective, it's extremely secure. Most of the attacks that are possible are more like everyday attacks on like the software or the UX or the laptop. So what a lot of people who own Bitcoins, they actually have computers. This is very fascinating. They have computers that they have never connected to the internet. They have computers that they've never used where they think there might be public cameras somewhere. So it's like, imagine this like secure laptop that you have never connected.
Yeah.
You haven't installed any like random software on it ever. And you generate your private key on that computer, like sitting in a dark room so that, you know, and then you use that private key to keep your Bitcoins on the account that is owned by that private key.
Whoa.
Right. So, and there are companies that do like, you can actually store your private keys in cold storage in banks and vaults. Like imagine now people are keeping millions of dollars of their money in Bitcoins. So imagine the level of security around these private keys that like you would need signatures from multiple people before a transaction can happen, and like all of that stuff is
wow.
Yeah.
Some password.
Get like extra money for it, you know,
Like
money.
Like
I mean,
like in
is it only like I can only use it, let's say, on the internet to buy things, or can I actually get money?
yes, you can, absolutely can. So there are, what's happening is that there are companies which are called Bitcoin exchanges, right? And they act like, you know, how you can convert your euros to dollars, you convert Bitcoins to dollars.
Okay.
And people now, there are professional traders who can actually trade this currency, and it's
I
like,
think there's even like an ATM in Brooklyn
Yes.
that you can put your money into and get, because I heard it on Radio Lab, there was a story of this like grandma that had to go to do this.
Yeah.
Is there like any amount that they cannot exchange, or is it like?
So it
whatever
really,
that-
so think of this as like that is dependent on that company, like how many Bitcoins they have, how many do they have in store, and like what's the exchange rate right now. And there are multiple companies now. There are like a bunch of
So if I
exchanges.
have, like a couple of millions,
Yeah.
I would probably have to.
So one of the companies I mentioned, Coinbase, who have raised like $100 million, they are an exchange, right? So they keep actually millions of dollars in Bitcoin for their customers. So basically, we already talked about this. So what I said, the public key was like, which is like a username on Twitter. It can be something like a bank account number as well. So imagine that you can convert that into something like a bank account number, and looks like this. And this is what people use for Bitcoin payments. Whenever they say, hey, give me your Bitcoin address, I want to send money to it, it's this address.
The
Which-
public, this one.
It is derived from the public key,
Okay.
right? So it's technically it's like a hash, double hash of the public key, but you don't need to know that. It's basically think of it as a bank account number. But the interesting thing is that it's not like your bank account number for the rest of your life, because I can generate new addresses very, very quickly. Like imagine like instead of creating one private key on my computer, I can create 1,000 or more. Like it's like within it doesn't take that long. Right? So I can have like as many accounts as I want, and I can use them.
So it's much more secure because if you have somebody's bank account,
yeah, exactly,
you can't change it.
Right. So some people even say you should just use one address only once and just throw it away.
Wow.
And move like, so imagine like if I had $20 in my account, I wanted to send you 10. I send 10 to you, and I send 10 to an address that I own, but it's a new address. So no one really knows like
Wild.
how the money is actually flowing in the system. So now let's try to make a transaction, right? Like you're just a user. You know that. So there are companies now who actually make these Bitcoin wallets. So it's like an app. You download the app. You send yourself some Bitcoins from an exchange, right? You bought either like the app will have the functionality that you can just say fund your account, convert $5 to Bitcoins, or you would send yourself money from just like you can treat some of the exchanges as your bank account, and then you're kind of like sending money to an app that is your wallet, and you can use that for payments. You can like buy coffee with this. Like there are a lot of merchants who are accepting. I think Target started.
Really?
Yeah, there are some big companies like Microsoft accepts payments in Bitcoins for certain things like the Xbox or.
Oh, cool.
I'm not exactly sure what product it was, but it's like definitely there's a massive increase in people who are accepting Bitcoin as payments because they're actually not taking that much risk, because you can set up your website that you can accept the payment in Bitcoin, but as soon as you accept it, you cash out $2.
Oh, wow. And then there's probably not a transaction fee like credit cards have, huh?
Yes, so Bitcoin transaction fees are very low.
Yeah.
There are fees. That is actually, that didn't come up in the discussion about how new money is getting introduced. The second form of payments is actually transaction fees, which are very small. Okay. But if there are enough transactions, the miners can collect fee from, let's say, 1,000 transactions.
Yeah.
And so that's another incentive for these people to keep running their computers on the network, because when, let's say, a couple of decades from now, the amount of new money being released goes down, still there will be transaction fees, and Bitcoin would be a lot more valuable by then. So they would still want to continue running the network because of the transaction fees.
I mean, and the reason we need all the computers on the network is because that's where the log is, right? It's like distributed, like everybody has a copy.
Exactly. And another way to think about it is if a large bank is running computers and the infrastructure, right? They're collecting fees from their customers and they are responsible for running the infrastructure, but now you're dependent on the bank. This is Bitcoin's way of getting people to run all of these servers and infrastructure, and it's being operated in a way that no single person is in control. But still there's massive computing and networking power behind the technology, and which is fine. Like you don't care like how the infrastructure is run. It's actually better for me if no single company has control over it, right? And the protocol just figured out a way to give people incentive to basically plug in their computers and help the network.
Got it. Cool.
So let's say you want to do a transaction. The transactions are, you can just think of it as like writing a check. Just like you sign a check, you can sign a transaction with your private key. And that's all there is. So if I want to send, like, let's say a Bitcoin to Chris, I would need to know his Bitcoin address. Then I will sign the transaction with my private key. And so most of these wallets and exchanges would take care of this for you, right? Like you wouldn't even notice. It would feel like a normal payment to you.
Just press send.
Yeah, they would just, you would just say click on send, and things would just happen. But at a more technical level, what's happening is, let's say I wanted to send it from my laptop using the open source software or something, right? So I would create this transaction, sign it with my private key, and broadcast it to the network. And in the network, what happens is that the next block is being prepared, like over here, right? So remember that any change that happened or any transactions that happen, they go into the next block. So some miner, whoever wins the puzzle, will take all the transactions, pack them, and basically write the next block of the blockchain. Because the miner is getting transaction fees from the transactions, so the miner has incentive to include your transaction as well. And interestingly, sometimes people send transaction with no fee, and sometimes miners just accept that as well. I think there was a famous transaction where the money that was being exchanged was in the order of millions, and the transaction fee was 0, but someone still included that, some miner still included that, and the transaction went through. So it became like a meme that in Bitcoin you can actually transfer millions of dollars and pay 0 in fees. But usually the fees is actually in the order of cents. Like I usually pay like 20 cents for making a transaction.
For a transaction.
Yeah, and it's usually good enough that miners will pick it up very quickly.
Huh. Fascinating.
So this is how like they pack transactions, and then the blockchain just basically keeps growing. And I'm gonna skip this slide. This is about the actual how the puzzle works. But if people are interested in like how the puzzle is designed, I can explain it. But that was you are okay. So here's how the puzzle works, right?
Okay.
So there are 2 conditions or 2 properties that the puzzle should have. It should be very hard to calculate, but very easy to verify that you got the right solution, right? And it should be dependent in some way on the previous history, right? So that you know that you're working on the next block. So what happens is that, so this is a block that is currently being prepared and it has not been written yet, right? So it has a reference to the previous block, right? And you have a bunch of transactions here. So the miners are supposed to like take all of this information, including the pointer to the previous block, right? And hash it. So hash functions are where you just take a bunch of data and it's a one-way operation. And it basically, it's deterministic, that whatever data you basically give to the hash function, it will give this. If you give the same data, it will give the same output. So it basically converts any data. Let's say I give it A, B, C, D, E, F something, it will output some string of characters or numbers, which will always be the same if I give it the same input. Right? So it's like a one-way hash. It gives you like a hash for a certain value. So what these people are trying to do is that they're taking this data, which is constant, right? Everyone has the same data. And then they have it's called a nonce. This value they can change. So they're like changing the nonce again and again to get different hashes.
Just random generating
randomly.
numbers.
So
Random
imagine
numbers.
as soon as the next block comes in, everyone like just fires up their computers and they're calculating hashes upon hashes upon hashes, right? Because they're just incrementing this nonce and just randomly what they're trying to get at is, for some value of this nonce, you will get a certain number of zeros at the beginning of the hash. So the hash looks something like this, right? But the probability of hitting that is actually very low. Wow. So you are kind of like basically doing a brute force attack to randomly get a hash that matches this criteria. As soon as you hit that hash randomly, you tell everyone, hey, I got it. Give me Bitcoins. Right? So, and it's very fascinating the way they designed it, because the protocol is actually even intelligent enough to see how many people are playing the game. If, let's say, for some reason it's not profitable for you to mine anymore, let's say the cost of electricity is a lot, and you're actually losing money because you just don't find the hash realistically over time, and let's say half of the network just drops out.
It gets easier?
I don't want to play it anymore.
Yeah.
The game becomes easier.
Get out of here.
Seriously.
That's cool.
So, and usually how that happens is technically they would drop a 0. So now it's easier to get 4 zeros in the beginning randomly than it is to get 5 zeros. Like imagine like you're playing cards or something. The probability of you getting like an ace is actually much lower than getting ace and an ace, right? So the zeros are like that. So the protocol actually adjusts and everyone's like, hey, there's free money on the table. Now it's easier to mine. Why don't you plug your computers back in? So it like keeps actually giving incentives to people
Wow.
to be part of the network.
Are there any banks that are starting to take advantage of blockchain technology?
Yeah, it's very interesting. Like what I've noticed in the financial sector is that initially when Bitcoin came around, like, you know, just like any new crazy technology, like they were just making fun of it. And then especially because of the hacks, like imagine like the first exchange where you can go and like convert dollars into Bitcoins. The first big one was called Mt. Gox. It was in Japan. And there was a major problem with it. It was like run by, I would say, people who weren't that professional, and then they actually lost a lot of money of their users because there was some hack that they tried to cover up, and it went under, it went bankrupt, and people lost a lot of money there. So everyone used that as an example to say Bitcoin wouldn't work, which is like saying one bank shut down, so the entire technology is broken, right? Like there will be other exchanges, there will be, so, and then interestingly, I would say maybe 2 years back or a year and a half back, the conversation shifted from Bitcoin to blockchain. So blockchain is the underlying technology, and Bitcoin is kind of like, you can think of it as like one application, although it's not entirely fair to Bitcoin, because as you saw like with the mining stuff, that the currency is actually required for incentives for running the network. So you can't really have a blockchain without having any incentives for people to actually like run the system. But interestingly, banks love blockchain. So now there are all these conferences where all the banks are there and they're like, yeah, blockchains are amazing. And they're trying to figure out ways to kind of like have private versions of this. So it's a blockchain which is like gives you certain benefits like auditability, you can roll back things, and but they just want to have a blockchain between like, let's say 6 banks, not like this open permissionless system like Bitcoin is. And there might be a space for it. Like I think of it as like how there's the public internet that anyone can connect to, but then there are these secure company networks that, you know, large companies operate and you can't really get access to it. So there's probably a space for private blockchains as well, but that is what banks are most interested in right now. And I personally feel that this also gave banks ammunition against Bitcoin. They're like, hey, blockchain is like the real thing. Bitcoin, yeah, no, I don't know if that's ever going to happen.
Great. Any other questions, guys? Yeah, Chris.
Can you just talk a little more about how the same technology that powers Bitcoin, what you talked about with the linear data stream, also can store my data, and how can it do so many different things?
Yeah, sure. So I think at a high level, so we talked about this a little bit, that you need some party or something to decide what is the reality, right? So in terms of the currency thing, we saw how banks usually say that, hey, yes, Muneeb has $20 in his account, and we take the word of the bank, right? If you apply this analogy to Twitter, any content that is on Twitter or my ownership of @Muneeb is basically there because Twitter says it's there, right? Like Twitter has it somewhere in their databases, right? And they say that, yes, the person who logs in with @Muneeb and a password has this thing, but they can take it away at any time. Like they do it all the time. They shut down accounts, they censor tweets, like they cut down access to applications. Like I think when they bought Periscope, they basically stopped giving access to their competitor and then bought Periscope. So it's like Twitter is like kind of like playing God in the middle, right? Like, and what this technology does is that it replaces any company by this network where you can go to the network to decide what is the reality. So the example would be, I claim that I registered @Muneeb, right? But now there is a public record of that in a transaction in the blockchain, where now I was able to register it because nobody else registered it before me, and that is the protocol, and now I have it, and it's linked to my private key, right? And then I will have like a pointer to the rest of my data, right? That's how our system is designed. So imagine the blockchain only comes in for conflict resolution and for basically deciding who owns what online. It's kind of like property rights, right? Like the currency is a form of property, but you can have other forms of property as well, right? So one form of property that I have is my data, but I'm not putting all the data in the blockchain. I'm just putting a pointer to my data in the blockchain.
But where is the data?
So the way we designed our system is we treat like all of these like cloud computing providers as like dumb hard drives.
Okay.
Right? Like imagine like I have my laptop over here. I don't even know who's the manufacturer of the hard drive.
Okay.
Right? And I can copy my data from my laptop to my iMac. Again, I don't know who is the manufacturer of the hard drive.
The hard drive in the computer.
In the computer.
Yeah.
Like you don't know. Nobody knows,
Nobody
right?
knows,
Like,
yeah.
it's dumb hard drives. I don't care who made it. I'm just like putting my data there, right? Similarly, the cloud providers, the Google G Drive or the Dropbox or Amazon S3, it shouldn't matter where you're putting your data. They should be like dumb hard drives, and that's how we treat them. So,
so you're decoupling my email for G Drive, like my identity with the data.
Yeah,
So
so
the data is being stored somewhere. It's just
the
nobody
data
knows.
is being but what we are doing is we are putting encrypted data blobs in your Dropbox account, right? But Dropbox has they don't know what is this data. Like you're just putting like this gibberish big file on Dropbox.
Got it.
And there's a pointer to that in a file from the blockchain, right? And all of this is signed by you, right? So when someone who actually has access to read it, they can actually verify that this was signed by you. So this is actually like way more secure than the current internet. Like let me give you an example of a blog post. Right now you would go on Medium and you would just publish your blog post, right? Like, it's very similar to the same thing. Medium now has all the content. You have to log into Medium, and people used to run their own blogs, and they actually used to enjoy that. They would feel that they have more control over their blog, and they can do that. Now imagine like an even more secure or more decentralized system where to publish a blog post, all you have to do is like sign it and just put it in your Dropbox. But there is a way for people to load the blog post at muneeb.id, right? Or whatever. So just like their domain names, like facebook.com or, on the traditional internet, we built that for blockchain. So there's like domains like .id, .app, .something else. So imagine like going to twitter.app, but what you're seeing is actually tweets by people that is being read from their cloud storage and just displayed exactly how Twitter would display it, right? At the infrastructure level, the technology is very similar because Twitter has a data center, and there are multiple data centers, and they serve the data to you whenever you go to twitter.com. We use the same infrastructure. It's like all these data centers of Dropbox and Amazon and Google and whoever else. But now these companies have no control. So you load the data, you display it in this new browser in a way that it's a direct connection between the user who owns it and like the person who's using the app.
That's cool. That makes a lot of sense.
So this was like, by the way, this would like take an entire lecture on the architecture, but this is like a very quick summary or a compressed form of the information. So I hope that made sense.
Yeah. Cool. Awesome. Well, thanks so much, Muneeb, for coming by and giving us this talk. Really great. Give another clap. Yeah. Awesome. Sweet. And where can people find you? website or
yeah, so
right here?
If you have more comments, like especially people who are watching online, you can just tweet them at Muneeb.
Great.
And our website is blockstack.org. Think of it as like we are working on the next browser, but browser is like just the interface. We had to invent the new internet in the background, like, and all of that is like something we have built over the last 2 years, and it's open source. If you're a developer, you can actually just like join in our public Slack channel. It has over 1,000 developers working on this, and yeah, we are extremely excited about what the future of the internet is going to look like.
Awesome, cool. Thanks so much, brother.